Try to mentally multiply 97 by 96. You have 5 seconds. For most of us, that time limit usually means reaching for a calculator. But there is a specific algorithmic framework built exactly for this kind of problem. It's called the base 100 trick. The strategy works because 97 and 96 sit just below 100. Instead of dealing with the large values directly, we treat 100 as our fixed mathematical anchor point. Step 1 is figuring out exactly how far away our starting numbers are from that anchor. 97 is a -3, and 96 is a -4. By treating the problem this way, we entirely avoid multiplying large numbers. We convert a heavy mental calculation into basic single-digit subtraction. Let's set up the starting board. We have our baseline problem at the top and our negative distances of -3 and -4 directly below. This brings us to the critical first mechanical step, cross subtraction. We must subtract diagonally. Do not subtract straight down. There is a built-in mathematical symmetry to this step. If you take 97 minus 4, you get 93. And if you take 96 minus 3, you also get 93. Either path resolves to the exact same number, providing the first half of our final answer. For the second phase, we ignore the starting numbers entirely. Our focus shifts directly down to the negative differences. Now we multiply those two differences together. A -3 times a -4 yields a +12. That resulting product forms the final 2 digits of our answer. We place the 12 right next to the 93, bringing our final total to 9,312. Bypassing traditional carryover arithmetic clears up your working memory. You decouple the math into simple cross-subtraction for the front half and basic multiplication for the back. To see where the structure is vulnerable, let's test the limits of the algorithm with a new problem, 99 times 98. The negative distances are -1 and -2. We run the first step exactly as before. 99 minus 2, or 98 minus 1, cross-subtracts to 97. That confirms our first 2 digits. But here is the failure point. When we multiply our negative differences, we get a single digit, 2. Appending that straight to our prefix gives us 972, an incorrect 3-digit answer. The algorithm dictates a strict 2-digit rule for the back half of the calculation. To satisfy that rule, we must insert a placeholder 0 before the 2, yielding the correct output, 9,702. Recognizing structural constraints prevents errors. If the multiplied difference is a single digit, inserting the 0 is mandatory to maintain the output format. Now it's time to test your independent comprehension. Let's look at 94 times 97. Pause the video right here. Find your negative distances, execute the cross-subtraction, and multiply for your final digits. Hold your final answer. Let's run it. The distances are -6 and -3. Cross-subtracting 94 minus 3 gives us 91. Multiplying 6 by 3 gives us 18. The answer is 9,118. The entire operational method distills down to a strict 3-step list. 1. Find the negative distances from 100. 2. Cross-subtract to lock in the first digits. 3. Multiply the distances to lock in the last 2 digits, remembering your 0 placeholder if needed. By internalizing this specific algorithmic shortcut, a calculation that once demanded a calculator becomes a reliable, everyday cognitive tool.